Hi, today we are going to show a solution to how to find eigenvalues and eigenvector of a matrix. As given, this is a question, an example of question of an eigenvalue eigenvector solution. Find the eigenvalues and eigenvectors of the matrix of A. As you can see, this is a matrix A where we have the following. So the solution to solve such a question, the first step would be to use the lambda, which is as such: u lambda I minus A. So this application in the above matrix will give lambda minus 5, 4, 2, 4, lambda minus 5 again, because as you can see the matrix, and 2 and 2 here, another lambda minus 2, not forgetting our negative since we have inversed and this is the matrix that you get when you apply as such. Now the next step would be to solve this equation into into a determinants equation. When you do so, what you get is lambda minus 1 square lambda minus 10 equals to 0. Thus we are given three unknowns and three values of lambda, which are lambda equals to 1, giving this, another one since it's square, and 10. Now for the second step. We have to find the eigenvalues and vectors for 1 and 10. Now let's start off with 1. What we have to do here is substitute the lambda into this formula here. So it will be 1 I, seeing that we put the lambda, minus A, which would equal to -4, -4, -2. You see how we got -4 was substituting the 1 into this lambda here. So we get -4. So 1 minus 4. And thus we have to do the same thing for the other as well. So we get -4, -4, -2, -2, -1, x1, x2, x3 is equals to 0. And by solving this, we get x equals to changing that, you get S T S2T. These are just unknowns, so that would be easy for us to solve, and thus giving us -1 1 0 Thus, these are the eigenvalues associated with the following. Next, we shall go for lambda equals to 10. If lambda equals to 10, the same thing, n minus a x will give us 5, -4, -2, -4, 5, and -2, -2, -2, 8, x1, x2, x3 equals to 0, and thus we get, notice how earlier I used S and T and now I'm using R. It's just to differentiate, to show you the unknowns. It can be any unknown, it's just an unknown. So in this case will be x1 will be 2r, x2 will be 2r, and x3 will be r, which makes 2r, this one, and so it gives you 2r, 2r, and r equals to 2, 2, and 1, and that is the eigenvector associated with the eigenvalue lambda equals to 10. So for lambda equals to 10, eigenvector is such, and for lambda equals to 1, the eigenvalue is as such.